Engineered Controls International Incorporated, the manufacturer of Rigo products, presents an introduction to propane container valves. When properly sized and maintained, propane gas containers provide a continuous gas supply to a variety of installations. To meet the requirements of the different types of installations, propane containers are available in a wide range of sizes and conform to different standards. For example, DOT cylinders conform to the requirements set by the Department of Transportation. In domestic installations, they range in size from 100 to 420 pounds, and they may be transported with up to 80% of their maximum allowable capacity. ASME tanks have specifications set by the American Society of Mechanical Engineers. Domestic ASME tanks are available in sizes up to 2,000 gallons capacity. They may not be transported with more than 5% of their maximum capacity, and they must be filled on site. In the containers, propane gas is stored in a liquid state, with vapor occupying the space above the liquid. The pressure of the gas and the container's vaporization capacity vary according to temperature, the level of liquid in the container, and the amount of gas being used by the system. Vital to the safe handling and storage of gas in these containers are the propane container valves. Propane containers are equipped with valves that perform 4 basic functions: filling the container, vapor service withdrawal, excess pressure relief, and tank evacuations. To meet different needs, Rigo valves are designed in a variety of sizes and configurations, many valves incorporating more than one function. Regardless of the configuration, the design and operation is basically the same for each. 3 basic valves are used in the filling operation. The container is equipped with a fixed liquid level gauge and a filler valve. A hose end valve supplies the connection from the delivery source. During a filling operation, the fixed liquid level gauge shows when liquid has reached the maximum allowable level. You may see these gauges incorporated into service valves, multi-valves, or they may be independent in the container. The main components of a fixed liquid level gauge are a soft seat incorporated directly into the valve stem and a hollow dip tube which extends into the container. The length of the tube is determined by the maximum allowable liquid fill level of the container. The valve is opened prior to the filling operation to ensure that the container is not already at its maximum level or completely empty. When the propane liquid level is below the bottom of the tube, the pressure in the container forces the vapor out through the valve's orifice. During filling, when the liquid level reaches the bottom of the dip tube, liquid is forced up the tube and out through the orifice. This indicates the container has been filled to its maximum allowable level. A noticeably different discharge, similar to a white fog, indicates that filling should stop immediately. The fixed liquid level gauge is closed by turning the stem clockwise. The filler valve allows the transfer of liquid propane into the container. Like the fixed liquid level gauge, filler valves may be incorporated into multi-valves, or they may be installed directly into the container. When performing liquid transfers, be sure to wear eye protection and gloves, suitable to prevent liquid from coming in contact with hands. The most common filler valve design is the double back check valve. As its name implies, it's designed with both an upper check and a lower check device. The lower back check device typically has a metal disc. This restricts gas flow from the container but allows gas vapor into the valve. The upper back check uses a resilient soft seat designed to provide a gas-tight seal. When the filler valve is in the closed position, the 2 filler valve checks are held closed by the force of their springs and the force from the vapor pressure. In the event of an accidental pull-away, there is an undercut below the hose connection and above the seats. This provides a shear point, which allows both checks to remain in place and prevents an uncontrolled discharge of gas. A hose end valve connects the source of liquid propane to the filler valve. It serves as a shut-off device on the hose running from the delivery truck tank. Before starting any filling operations, check for foreign materials in the hose end valve and the filler valve. Carefully remove any contamination. If contamination cannot be removed, do not proceed with filling and contact your supervisor. The proper placement of the filler valve's seal gasket should also be verified. A swivel attached to the hose end valve and an easy-to-grip connector make connection to the filler valve simple. The Acme connector should spin on easily by hand. A rotating and self-locking handle makes it easy to use from any angle, and it's designed to prevent accidental openings. In the closed position, the hose end valve has a gas-tight seal. This seal is formed by a resilient seat disc, the downward force from a spring, and the pressure from the delivery truck tank. To open the valve, the handle is lifted, pulling the seat disc away from the metal seating surface. Gas can now flow from the delivery source to the container's filler valve. If any leaks are noticed, stop, close the valve, and correct the condition. When liquid gas is pumped from the delivery source, the pressure above the check valves becomes greater than the force of both the filler valve springs and the container pressure, causing the checks to open. Liquid propane can now flow from the delivery source through the hose end and filler valves to fill the container. When the container's been filled to the desired level, the pump should be turned off. The two closing springs will now force both check devices in the filler valve back to their closed positions. The hose end valve should now be closed. A small amount of gas will be trapped between the seat of the valve and the upper check of the filler valve. When using the Rego A7797, this gas is removed by turning the connection about a quarter turn. Some valves may be equipped with a bleeder valve. Do not fully disconnect a hose end valve until the gas stops bleeding. If gas continues to bleed, stop and check the hose end valve to be sure it's closed. Tapping the side of the filler valve with a non-metal item like the dust cap may help close the valve. If the hose end valve is equipped with a removable filler hose adapter, be sure the adapter is threaded tightly onto the Acme threads of the filler valve. Remove the hose end valve from the adapter and install the dust cap. If bleeding persists and you don't have a special check adapter on the end of the hose, retighten the connection, leave the hose connected, and contact your supervisor. When the gas bleed stops, the hose end valve may be removed. Never stick a foreign object into a filler valve. It will damage the resilient seat. After you've made the disconnection, make sure that the filler valve has properly sealed off, and then just securely replace the Acme cap. Most ASME containers are equipped with a vapor equalizing valve. They're also available as a function of the multi-valve or as an independent valve. The vapor equalizing valve allows the pressure, which builds in the container during filling, to be displaced back to the delivery truck tank, equalizing the pressure and making the filling operation faster. The vapor equalizing valve is connected to the delivery truck tank by a hose and a special connector. The valve has two main components: a back check valve with a resilient seat and an excess flow valve. When not in use, the force from a spring and the pressure in the container keep the back check in the closed position. The soft seat provides a gas-tight seal. The force from a second spring holds the excess flow open. When the hose and special connector are threaded onto the vapor equalizing valve's outlet, the upper back check is pushed down, opening the valve, allowing vapor to exit back through the hose and into the delivery truck tank. The vapor equalizing valve also has an excess flow feature. If the flow of vapor through the valve should exceed a predetermined point, the flow creates a pressure drop, which overcomes the force of the spring, causing the valve to close. Since these valves allow a small amount of vapor to be transferred from the container, they're not allowed by law in some states due to weights and measures requirements. Vapor equalizing valves are also used as a connection to the compressor when a container is being evacuated, and as a connection for a vapor eliminator line from a propane gas dispenser that incorporates a liquid meter. Service valves are used to allow a flow of vapor out of the container and into the system being served. A regulator, usually connected to the valve with a pigtail, controls the gas pressure. This service connection is usually provided as part of a multi-valve, which can incorporate various other functions. Vapor service valves provide reliable hand-tight closings by using seat disc and stem seals made of synthetic rubber and nylon. In the closed position, the resilient seat disc prevents vapor from leaving the tank. The valve is opened by turning the hand wheel counterclockwise. This lifts the seat disc away from the body, allowing vapor to flow into the system. Hand wheels should be fully open during service, creating a back seat and providing for maximum flow through the valve. Seals around the valve stem are designed to prevent gas leakage. The valve is closed by turning the hand wheel clockwise. With the resilient seats, a hand-tight closure is all that's necessary. Never use wrenches on service valve hand wheels. Another unique feature found on many Rego service valves is the patented multi-bonnet, indicated by the multi-bonnet nameplate. During service, when valves are completely open and back-seated, repair of bonnet packings may be made without interrupting gas service or evacuating the container. In this position, after removing the screw and hand wheel, the upper bonnet packing assembly is isolated, and it can be removed without interrupting the gas service. A new upper bonnet packing with new internal and external seals can then be installed. The multi-bonnet makes replacement of the stem seals quick and easy. Repairs should be done by experienced personnel, following instructions provided with multi-bonnet repair kits. One of the most important valves in an LP gas container is the pressure relief valve. They can be incorporated into the multi-valve, or as it is here, found as an independent valve. The pressure relief valve is designed to protect the container from catastrophic failures caused by extremely high pressures. These hazardous conditions can result from overfilling, exposure of the container to excessive external heat, the use of incorrect fuel, or improper purging of the container. Proper purging instructions can be found in the Rego Serviceman's Manual. The design of relief valves varies from container to container, yet the components and operating principles are basically the same. The relief valve has three major components: the body, a spring, and a seat disc and retainer assembly. A resilient seat disc provides gas-tight seals. In the closed position, force from the spring holds the seat disc securely against the valve's metal seat. Vapor pressure exerts an opposite force against the seat disc. Should this pressure build to the point where the force is greater than the force from the spring, the stem and seat disc assembly rise a small distance, and gas vents to the atmosphere. If the container pressure stops rising and starts to drop due to this venting action, the force from the spring returns the seat disc to the closed position. However, if this initial venting of gas fails to control the pressure buildup and pressure continues to rise in the container, the seat disc will move to a full open position with a sudden pop, allowing a large volume of gas to vent from the container. When enough gas vents so that the force from the gas pressure falls below the force of the spring, the valve is designed to reseat and stop the flow of gas. When a valve has popped to the full open position, the reseat pressure will be less than the set pressure stamped on the valve. Relief valves on containers which have popped fully open should be replaced, or they should be removed from service and inspected by knowledgeable personnel to make sure they're in good operating condition and that there are no foreign particles which would prevent the valve from reseating to the gas-tight position. All relief valves should be inspected regularly. When inspecting, remember to always wear eye protection and never look directly into the outlet of the valve. Valves should be inspected to make sure that they have open weep holes, are free from signs of deterioration or corrosion, physical damage, tampering or readjustment, leaks, contamination, foreign objects, or debris in the outlet, and that there is a protective cap in place at all times. Damaged or missing caps should be replaced at once. Under normal conditions, the recommended life of a relief valve is 10 years from the original manufacture date. However, this life may be shortened and replacement required earlier, depending on the environment. Evacuation may be necessary for unexpected repairs or when transporting large ASME containers. ASME tanks over 125 gallons water capacity may not be transported with more than 5% of their capacity in liquid. Actuated liquid evacuation valves provide a way to withdraw liquid propane from the container. Rego Products evacuation valves are called check locks. In new propane containers, they're most commonly mounted on the top, but they may also be found on the side or in the bottom. Top-mounted check locks are fitted into a special container opening with a dip tube extending down to the bottom of the container. In the closed position, the check lock serves as a back check valve. A resilient seat is held securely in place by both the force of a spring and the force from the gas pressure inside the container. A second seal between the stem and seat assembly is also held in place by the force of this upper spring. Since evacuation involves liquid transfer, suitable gloves and eye protection must be worn. When using the check lock for liquid withdrawal, the protective cap is first loosened. This allows any accumulated gas to vent through a hole in the cap. After the venting stops, the cap may be removed. If venting continues, immediately retighten the cap and use another suitable method to remove the liquid. A transfer valve fitted with a Rego check lock adapter is used to connect to the check lock valve. The hand wheel must be fully open before making a connection. Use of the Rego adapters provides for proper operation and prevents damage to the check lock. When the transfer valve and adapter are completely threaded onto the evacuation valve, the adapter pushes the stem into an open position. After making this connection, the transfer valve should immediately be shut off by turning the hand wheel clockwise. The force from the container pressure keeps the seat disc in the closed position. Propane liquid now flows around the stem into the body of the valve. When the liquid pressure equalizes above and below the seat disc, the lower spring pushes the seat open and liquid flows to the transfer valve. The transfer valve may now be used to allow flow from the container. Be sure the transfer valve is fully open during transfer operations. If the check lock fails to open, you may need to help equalize the pressure above and below the seat disc by increasing pressure downstream of the transfer valve. Pressure can be increased by introducing vapor from the container's vapor return or service valve or from a hose end valve connected to the delivery truck. When the evacuation of the container is complete, the transfer valve should be closed. The transfer hose can be removed only after venting any trapped liquid or vapor. Now, before removing the transfer valve and adapter from the check lock, quickly reopen the transfer valve. This should cause the check lock's excess flow to slug closed. After slugging the valve closed, a very small amount of gas will continue to bleed through the excess flow valve. The transfer valve and adapter may now be removed. There must be at least 35 pounds pressure in the container for the seat disc to slug closed. If the excess flow feature fails to close the check lock, evacuate all the remaining liquid from the container. After this evacuation, again attempt to slug the excess flow valve closed with vapor flow. If the valve still will not slug closed, close the transfer valve and contact your supervisor. After evacuation, the check lock outlet should be cleaned of any debris and the protective cap reinstalled securely. Rego Products is committed to offering the most complete line of equipment for the propane gas industry. Over the years, Rego product engineers, in conjunction with gas marketers, have pioneered the development of propane container valves to meet the needs of the propane industry. The Rego multi-valve was developed by Rego product engineers in the early years of the propane industry. The multi-valve has made more practical tank designs possible, designs with fewer openings and smaller, less cumbersome hoods. The multi-valve design remains an industry standard throughout the world. Many other Rego products designs have also set industry standards. Double-check fill valves, pop-action relief valves, check locks, the multi-bonnet. All Rego equipment is designed specifically for the propane gas industry, is manufactured with the highest quality components, and is 100% tested for reliable performance. Be sure to specify Rego valves on your next container purchase.